These B-cell disorders, right, like thyroidophagia, deficiency, and is not a vast book. So we only read down
First aid and comfort.
Others, which all of them, the B-cell disorders, three of them are there. And jobs is
Yes. Diseases which are not written in the ABAS are in the Kaplan and first aid, so you can use it.
So are you going to explain what the BNP cell?
Where is Ayesh? Maybe.
Diseases which involve ABAS are in Kaplan and first aid.
Yeah.
Was there IPEX? IPEX. Oh, IPEX is tolerance, I think. Yeah. Okay. In T and B cell disorders, the first one is severe combined immunodeficiency. Severe combined immunodeficiency has like many causes. We have different types of the severe combined immunodeficiency. We have autosomal recessive form, we have X-linked recessive form, and etc. The most common type is X-linked recessive type, during which we have defect in interleukin-2 receptor. What was the function of interleukin-2? Function of interleukin-2 was to activate and proliferate the T lymphocytes. Any type of T lymphocyte, CD4, CD8, or like regulatory T cells. So if you don't have interleukin-2 receptor, it means that you are not able to activate T lymphocyte, and inactivation of T lymphocyte will lead to the inactivation of the B cell, right? Because interleukins produced by helper T cell is crucial to cause the isotype switch. So in X-linked recessive form, we have deficiency of interleukin-2 receptor. Sometimes we have deficiency of enzyme which is called adenosine deaminase. What is the function of adenosine deaminase? Adenosine deaminase degrades adenine nucleotides, ATPs and ADPs and AMPs. Nucleotides are synthesized and degraded all the time because DNA synthesis occurs all the time in your cells, and we need this nucleotides, and also we need to degrade nucleotides which are like not anymore essential. So when you are degrading the adenine nucleotides, the one very important enzyme which participates in this degradation is adenosine deaminase. If you have adenosine deaminase deficiency, the nucleotides, which are, for example, ADP and ATP, will accumulate in your cell. any molecule which is phosphorylated, and if this phosphorylated molecule is accumulated in your cell, can lead to the cell damage because it can deplete the phosphate pools and it can lead to the apoptosis. So most commonly, this adenosine deaminase deficiency affects the T and B lymphocytes because these DATPs are accumulated in the T and B lymphocyte and they cause the damage to them, and because of that we have deficiency of these active T and B lymphocytes. Third reason why we have the severe combined immunodeficiency is defect in ROG1 and ROG2 genes. ROG1 and ROG2 code for the enzyme recombinase, which participates in the VDJ recombination. If you can't do VDJ recombination, it means that you are not able to produce different types of antibodies and different types of T cell receptors. So in severe combined immunodeficiency, you have problem with both of them, with T and B lymphocyte. And because of that, you have recurrent in all types of infections. What do I mean? Fungal infections, viral infections, parasitic infections, bacterial infections, like all types of infections. And the children which are affected by this disease, by severe combined immunodeficiency, most commonly have failure to thrive. What is failure to thrive? Failure to thrive is when when the children is retarded, like when the children has mental retardation and also growth retardation. So defect in this B and T lymphocyte interferes with the maturation of the infant, maturation not only in the mental state but also in the growth, because like height, the weight, and everything will be abnormal. Adenosine deaminase helps you to degrade adenine nucleotides. Adenine nucleotides, for example, a DATP, DAMP, and DATP. If you can't degrade these adenine nucleotides, these phosphated molecules will accumulate and will lead to the cell damage. And that's how the B and T lymphocytes are damaged. Like these DATPs are accumulated in their cytoplasm, and then this DATP causes the damage and they lose the function of T. They make the T and B lymphocytes non-functional. Okay. How can you diagnose this severe combined immunodeficiency? You can check immunoglobulin levels. All the immunoglobulins will be decreased. You can check secondary follicles. Secondary follicles will be underdeveloped. And also you can check for thymic shadow. Thymic shadow is absent in severe combined immunodeficiency, like in Dye-George syndrome. Just remember that we said that if you want to distinguish between severe combined immunodeficiency and Dye-George, you have to measure the calcium levels, because calcium levels are low only in Dye-George syndrome and not in the severe combined immunodeficiency. Okay, next is hyper-IgM syndrome. What is hyper-IgM syndrome? In hyper-IgM syndrome, we have defect in signaling between T and B lymphocyte. We know that T helper 2 cells activate the B lymphocyte and tell them what kind of antibody must be produced. And during the interaction, they use specific co-receptors, which are called CD40 and CD40 ligand. CD40 ligand is on the T lymphocytes and CD40 is on the B lymphocytes. In hyper-IgM syndrome, we have deficiency of CD40 ligand, which means that co-receptors, which are crucial for the activation, are deficient, and you are not able to cause the isotype switching in the B lymphocyte. So if you check the blood, you will see that all the antibodies are low in level, but IgM is high because IgM doesn't need isotype switching to be produced. Okay, so that is why we have hyper-IgM syndrome. In hyper-IgM syndrome, also we have many types of infections, like fungal infections, bacterial infections, opportunistic infections, which means what is the opportunistic pathogen? Pathogen pathogen which lives normally in your body. But when the immune system or when the flora of your body is disrupted, then these opportunistic pathogens will replicate and cause the actual disease. For example, let's say the Candida, which is the opportunistic fungi in our body, during the immunosuppression or during the disruption in your microflora will replicate and cause the diseases like vulvovaginitis, thrush, and etc. Third one is ataxia telangiectasia. What is ataxia telangiectasia? This disease not only affects the immune system, but it also affects different types of systems like nervous system, like vessels, and etc. And why? When we have some kind of damage to the cells, for example, damage caused by radiation. What kind of radiation do I mean? Like by the X-ray or by the UV radiation. During the radiation, your DNA is damaged. What kind of damage we can have? We can have, for example, formation of pyrimidine dimers, deamination of cytosinucleotides, and etc. And we know that when we have this type of mutations, we have specific repair mechanisms in our cells: nucleotide excision repair, base excision repair, and etc. In ataxia telangiectasia, we cannot detect the damages in our DNA, which means that we are not able to repair these mutations, and these mutations will accumulate and cause the severe consequences. The X-ray and radiation, when they affect your body, most commonly affect the cells which are proliferating very quickly. And the cells which are affected by this ataxia telangiectasia are not only the T and B lymphocytes, as I said. During ataxia telangiectasia, even this small amount of radiation can cause the damage to your T and B lymphocytes, to your capillaries, and to your cerebellum. What is the function of cerebellum? Cerebellum is responsible for the coordination. So if the cerebellum is affected, you may get the symptom which is called ataxia. Ataxia is uncoordinated movement. When you will hear about ataxia, always remember about the drunk people, because during when they are drunk, their movement is incoordinated. Okay, that is ataxia. Also, they have immunodeficiencies because T and B lymphocytes are affected, and we have recurrent bacterial, fungal, and viral infections. And capillaries are also affected, which causes the formation of angiomas, which are called telangiectasias. Telangiectasias are dilation of capillaries on your skin, which looks like the network. No, I said that the cells which are actively replicating are most commonly affected by the radiation and by the chemotherapeutic drugs, because these drugs act on the cells during their replication. For example, why do you have hair loss during the chemotherapy? Because hair follicles are dividing very rapidly. Also, the enterocytes and brush border of the enterocytes are replicating very quickly, and that's why you have longevity during chemotherapy and so on. This is the angiomas. That's the capillary dilations. Okay. The fourth disease in Wiskott-Aldrich. What do I want you to remember from this disease? You have to remember the hallmark symptom of and sign of the disease. For example, we had retained primary teeth in Job syndrome, yes? hypocalcemia in DiGeorge, absence of thymic shadow in DiGeorge and SCID, increased risk of Giardia lamblia infection in selective IgA deficiency, and etc. In Wiskott-Aldrich syndrome, you have defect in your cytoskeleton. Cytoskeleton is essential to maintain the cell integrity and also transport the molecule anterogradely or retrogradely. What do I mean? We have two motor proteins. Yes, I think you must know it. It is dynein and kinesin. Dynein transports the vesicles retrogradely, which means that from the axon to the cell body, and kinesin transports the vesicles from the cell body to the axonal end. In Wiskott-Aldrich syndrome, the cytoskeletal components of the cells are defective, and during this disease, the integrity of T and B lymphocytes is damaged, which means that they lose their shape, and when they lose their shape, also the biochemical pathways and different types of organelles are affected in this process. During Wiskott-Aldrich syndrome, we have also defect in our thrombocytes, which means that we will have increased risk of bleeding because thrombocyte platelets are essential to do the coagulation. Yes, so in Wiskott-Aldrich syndrome, together with immunodeficiency, you will see increased risk of bleeding, and you will see that if you check the blood of the patient, you will have low levels of thrombocytes. Okay. Phagocyte dysfunctions. From these phagocyte dysfunctions, we already know two of them. The first one is chronic granulomatous disease. And in chronic granulomatous disease, we have defect in NADPH oxidase, which is important enzyme to produce superoxide from the oxygen, and then from superoxide, hydrogen peroxide, hypochlorite, and etc. These reactive oxygen species are essential to degrade the bacterial membrane. We know that most of the time we are neutralizing this reactive oxygen species with the help of glutathione or with the help of hydrogen catalase enzymes, because they can cause damage to the mitochondria and cell death. But sometimes they are beneficial. What is the benefit of this reactive oxygen species? Like, they do oxygen dependent killing. If you have deficiency of NADPH oxidase, this means that you are not able to produce reactive oxygen species, and oxygen dependent killing is inhibited. So, what do we have to know about this disease? We have to know that if the patient is infected with catalase positive pathogen, this pathogen will disseminate and cause the severe infection. Why? Because the patient has low levels of hydrogen peroxide, and if the patient is infected with catalase positive pathogen, which secretes this catalase, even this small amount of reactive oxygen species will be neutralized, and you will not have any chance to fight against this bacteria with oxygen dependent killing. How do you diagnose this disease? We had two tests. One was nitrobutyrosolium test, during which you have like the affected cells do not turn blue, and we also had fluorescent test. In fluorescent test, the fluorescent is proportional to the levels of NADPH oxidase. Higher the levels of NADPH oxidase, higher the stronger the fluorescence. Okay, the second one is leukocyte adhesion deficiency. What was the defect in leukocyte adhesion deficiency? Defect was in tight adhesion because LFA1, which is also called CD1118, is deficient. If tight binding is disrupted, this means that leukocytes, which are like bound to the endothelium, can easily be detached, and we cannot recruit them to the site of infection. So in leukocyte adhesion deficiency, because we are not able to transport the leukocytes from the bloodstream into the tissue, we are not able to fight against the bacteria, and we are not able to mediate the acute inflammation. If you check the levels of leukocytes, they are high in number in the blood, because like the bone marrow gets the signal that there is some kind of infection in the tissues, and it starts to produce high amount of leukocytes. But in the tissue, the levels of the leukocytes are low because they cannot cross the endothelial membrane. What was the specific sign of this disease? It was delayed umbilical cord separation. Umbilical cord must be separated like after 1 or 2 weeks after birth. But in this disease, in leukocytic deficiency, you can see that umbilical cord separation takes more than 1 month. Okay. And the third one is Chediak Higashi. In Chediak Higashi, we have defect in fusion of phagosome and lysosome. Fusion of the phagosome and lysosome is very important because if you do not fuse phagosome with the lysosome, this means that lysosomal enzymes cannot reach the pathogen, and you are not able to kill this pathogen. Phagosome lysosome fusion is not only important for the killing of pathogen, it is also important to transport some kind of materials from the cell into the extracellular space. What kind of material? For example, the pigment melanin. Pigment melanin is produced and stored in some kind of vesicles, and these vesicles has to fuse with the lysosomes, and then they together are delivered to the plasma membrane, and then this melanin is released. In Chediak Higashi syndrome, the melanin cannot be released, which means that you may have the partial albinism in this disease. But not only the partial albinism, also immunodeficiency, because oxygen-independent killing is impaired. So if you have the case which tells you that you have recurrent bacterial infections or recurrent fungal infections, and you see that the patient has gray colored hair on or pale skin, you must think about the Chediak Higashi syndrome.
So again, repeat again, this melanin cannot be released.
Yes. Melanin is a pigment which gives the color to your skin and to your hair. Yes, so it is not released. If it is not released, it means that your skin and hair loses the color, and you have the like albinism. Okay.
Melanin normally cells.
In vesicles.
In every, in epithelial cells. That's Can you give me the cellular and molecular biology book?
We ordered on this PC.
No, just let me check something. Tomorrow I will give you the tolerance and allergy, and on Saturday laboratory techniques.
Energy.
How many hours? Only tomorrow is last.
Energy, tolerance, and laboratory ethics of
That means when I'm doing this,
You can go.
the